Atomic mass. Atomic mass from the very first day I'm telling you complete. What is atomic mass? And atomic number also. Atomic number is the number of protons. Atomic mass is the sum of protons and neutrons. Secondly, I told you if you see a symbol, two numbers written like sodium 1123, then the smaller number represents what? The atomic number. The bigger number represents what? The mass number. Okay? And this mass number is the sum of protons and neutrons. Now, as I told you that the atoms are very, very small, so small that it is not practically possible for anyone to find out the mass of single atom. All right? We want to find out the mass of a single atom. What is the way here? We use scales, weighing scales, like we use balance. So it's not practically possible to put a single atom in one of the pan and putting the weights to measure it in the other one. It's not possible. Moreover, the weights would be so of high value as compared to that little tiny single electron. Practically, it's not possible. So that is why scientists have chosen to compare to tell the masses a different way. They use what? They use carbon atom, carbon 12. Carbon 12 means its atomic mass is 12. They use carbon 12 to compare the masses of other elements. What does it mean? Comparison, what does it mean? Let me tell you. If we have a balance, this is one of the pan and this is another pan. Here we put something like we want to know the weight of oxygen. So we put an oxygen over here. Now, practically, we can't put our normal weights in this pan, in this weighing machine. So scientists chose what? Carbon 12, an atom, to find out its weight. Okay? So all the weights are the atomic, are the comparative masses. This is confusing. Okay, I'm trying to explain it. So what is the first point? Practically, it is not possible to find out the mass of a single atom. Secondly, scientists chosen carbon 12 to tell the comparative masses. All right, let me give you an example. Suppose we all are scientists and we agree that all the weights would be considered or would be measured by using this duster. So this would be our standard. So in one of the pan, we put this duster, and in the second one, we put that thing whose weight we are going to find out. Okay? So we will tell, for example, I am putting here my cell phone. So I tell you that I say that 5 dusters is equal, the 5 dusters are balancing single cell phone. So what would be the mass of my cell phone for this system? 5 cell phones. Okay, same duster. Now I'm putting what? This marker. I'll say this marker is the half of the mass of this duster. Okay, I'm putting here duster, and in the other one, let me put a cup of tea. I'll say the cup of tea is twice of this duster. So this is called comparative. There is another set of scientists, that those group of scientists, they choose rather what, instead of duster, they choose what, this marker for comparative studies. So they will tell you the masses by in comparison with this. Okay, so if I put myself in the pan, then what would be the mass? Might be 2000 markers. What is the weight of this one chair with this marker? Might be 150 markers. What is the chain? What is the mass of this these glasses as compared to this marker? Might be half, might be 0.7 of this. This is called comparative masses. So in the same way, scientists, they decided to find the masses of all the other elements with respect to carbon 12. Okay, now one thing is clear, carbon 12 has been chosen to find out the comparative masses of all the other elements. Next, suppose this is, I'm supposing this is carbon 12. They divided this carbon 12 into 12 pieces. Becoming difficult. Remember, you are not going to write or memorize all of these discussions. No, it's there in the book, but usually only the definition is asked. Okay, so just to tell the definition, I'm trying to give you some examples, trying to explain it. Otherwise, the definition you can rectificate it. So try to understand it. So carbon 12 is chosen. This is carbon 12. They divided the mass of carbon into 12 parts. This is one part. This is one part. This one part is called 1 AMU. This one part is called 1 AMU. AMU stands for atomic mass unit. So, refreshing, how are they using carbon 12? Instead of using the whole carbon 12, they are using its 12th part. They are comparing the mass of every atom, not with the whole carbon, but with only its 12th mass. 12 means 1 upon 12, whatever mass is at. Okay, so what if we summarize? Unable to find out the mass of a single atom by using ordinary common weighing scales, first point. Second point, they use carbon 12. How? By using the mass of carbon, the 1/12th mass of carbon. And what do you call this 1/12th mass of carbon? 1 AMU. In the whole world, this 1 AMU is not in our book. This 1 AMU is now called Dalton. So instead of writing AMU, they write Dalton, but it's not in our book. Okay, so don't write. You don't write AMU. Recall that example. Duster example. The mass of chair is 500. 500 dusters means 500 dusters. The 500 times of dusters is the mass of one chair. So similarly, if I write the mass of oxygen, I write here the mass of oxygen 16 AMU. It means an atom of oxygen has 16 times more mass than 1 AMU. The mass of sodium, let's suppose exactly 23 AMU. What does it mean? The mass of one sodium is 23 times than single AMU. What is single AMU? 1/12 mass of carbon atom. So try to understand it. If not, let me tell you individually in the group, or you can email it. I can explain it to you afterwards also. Okay, let's go back to the slides again. This is all what I was trying to explain it to you. It's there in your book also, same, more or less same. Okay, so we have covered. So if someone asks what is the definition of atomic mass, so what is the technical definition here? The atomic mass of an element is its mass, which is comparable, which is obtained after the comparison of one atom of carbon 12. Okay, now the next is molecule. Again, I told you two or more than two atoms combine to form a molecule. All right. Okay, now let's see the topic again on the screen. As I told you that we practice. For example, it is asked to find out the molecular mass of C6. Most of you might be knowing it, they have already done it. C6 H12O6. Okay, so the first one is carbon. I'm using the vertical method. What is the mass of one carbon? 12. How many carbons do we have here? What is the subscript here? 6. 12 6 are 72. Next, hydrogen. Yes. What is the mass of hydrogen? One hydrogen? 1. How many hydrogen do we have here? The subscript with hydrogen? 12. 1 12s are. Next, what is the mass of, what is the atomic mass of oxygen? 16 AMU, or simply 16. How many hydrogen oxygen do we have? 6. 16 6 are 96. Adding them all. So 180 AMU is its molecular mass. All right? Okay, doing it quickly by the other horizontal method, just for one time. C6 H12O6, carbon 12, plus hydrogen 1, plus 12 6 are 72. 1 12 are 12. 96. Adding them all, it will give you what? The previous answer, 180 AMU. See? Understood? Erasing it. You can take the screenshot if you want to take the screenshot. All right. See another example. Na2CO3. Its name is sodium carbonate. Sodium. What is the mass of sodium? 23. How many sodium? What is the subscript over here? 2. 46. Next is carbon. 12. How many carbons? No subscript means 1. Next, oxygen. 3. The subscript is 3. 16 3s are 48. Adding them all. 106 AMU. Is the comparative mass of sodium carbonate. Okay? Now, let's see a different example. Our last 2 examples. Okay. It depends on your common sense. Common mass. Aluminium sulfate. Aluminium sulfate. What is the difference between this question and the previous questions? Good. A bracket has been introduced. So there is a little bit change. What is the change? First one is aluminium. Can anyone tell me what is the mass of one aluminium atom? Atomic mass? 27. How many aluminiums do we have here? 2. 27 2s are 54. Next. Oh, the bracket has started. Now whatever we say is inside the bracket. So there is something different. Sulfur. What is the mass of single sulfur? 32. Here comes the point. The subscript which is written after the bracket, this would be multiplied by the number over here. What is the number over here for sulfur subscript? 1. So 3 1s are 3. How many sulfurs? You can see it's just 1. No. It's 3 written here. Outside the bracket, it would be multiplied by 8. 3 1s are 3. 96. Next is oxygen. The mass of oxygen is 16. Can anyone tell me that what should I write over here? How many oxygens do we have? What should we have to do? Since it is inside the bracket. Correct. 3 4s are 12. 3 4s are 12. So the next would be multiplying them, you'll get the answer. Okay? Is it clear? So, in this way you can calculate it. Just add them. So see what is the homework over here. Just for practice.
So this is your homework. Do the first part, question number 1 to 6. Okay, see you tomorrow. Thank you.